Hello, everyone. Welcome to a Wolfram Language Design Review, part of our Language Completeness and Consistency series. First up, table extensions.
Right. So in terms of sort of what we support, right, we
Oh, that's
have
a good idea. Sorry, go ahead. Yes.
um, right. So these are all things that are, working or mostly working, some documented, some undocumented, right? So we have the standard, min, max step.
hmm
Um, we have the list, which we've had, I believe, since V6.
Which
Um,
I haven't, which I've started using more and more, and I really like. And it's a
Good,
way of avoiding
good.
using map and so on.
Yeah, good, good, good.
yes.
Yeah.
Right.
It's
So
very
so
modern. Right.
Yes, right. We never documented it for whatever reason, but you could, instead of a list, put an association, and it would be equivalent to using the values of the
Okay, is
association.
that the best we can do there, or should it come back with a table that has the keys in it?
Well, I will, well, I would say that there are cases where you want both, and I don't, and absolutely, I don't think we should overload that into this case. I mean, we will come back to this case, but that right. I mean, what would you want? You would want I to bind to the rules?
No, I would want I to bind to what I would want here, and
Uh-huh.
perhaps it's crazy, is I would want the association, maybe this is crazy, f of 4, b, f of 5.
I think that is crazy. I think table has to produce a list.
All right.
Sorry. I think
Yeah,
that's
it produces
useful.
a list or list representation. There's one exception, which is if you give it a sparse array, it'll give a sparse
Okay,
out.
fine.
But then sparse are just lists in disguise.
Okay.
Right.
By the way, I'll just add something here that might frame this. I don't know if it's in the agenda because I hadn't talked to Itai about this. This is new to me, but I see this and I think, what about the control spec that is used by Manipulate and Friends, uh, which isn't, documented to be a standard iterator, but it shares all the documented things and none of the undocumented things.
Aha.
Wait a second. You're saying the thing that when I say manipulate.
Yeah.
So what's your point?
Yes, and what I'm saying is that if we're looking at expanding some stuff, and I'm just, framing this discussion that we should also consider whether or not these are appropriate extensions for that specification as well.
Fair
I mean,
point.
like the association specification, there's no reason we couldn't do that as a for example, but we didn't do it because I'm not sure anybody on my team was aware of it.
Okay. How do you get this functionality? Do we think we want to have something called association table or something? Because
Uh,
I think this is nice functionality. And if we're doing this for sparse arrays, this seems like the obvious generalization of that.
I propose something like that for a video as well, which obviously is insane, but that kind of functionality would be useful in that case as well. Anything that is list-like but not quite a list.
right. And yes, and those things are all here. In terms of something that actually returns an association, um,
I mean, given that you're saying it can return a sparse array, which I think is, I'm not
I think
100% on.
well, I would say, I mean, if we don't like the spark, well, I know
Okay, let
Rob
me understand what it does
contexts.
with a sparse array. Hold on 1 second. Can I actually run it?
Yes, absolutely.
Okay, all right. So if I say I, and then I say sparse array, and then I say 5 arrow 10, 11, 18 arrow 7.
Yep. So you'll get a sparse array that's 18 elements long, and default is f of 0, and then there are two explicit, if you open it up, you'll see that there are two explicit elements. Uh, well,
Well,
you can
okay,
do the
if
normal.
I
What
say
I'm saying,
array rules.
I meant click on the plus sign. But yes, that would also work.
See, that's directly analogous to what I'm proposing for the association.
No,
I
it's
like
not.
this.
No,
What's
it's
that?
not.
Why not?
Because sparse arrays are lists and
Well, they're
associations
not.
are
It
not.
says sparse array here.
No, but
No,
if you do
but come
normal on
on,
it,
Stephen.
if you
They're
do
array
normal,
queue. They are documented to return the corresponding right, when you do normal of them, you get a list out. None of, you know, you
But I
get a
mean,
list
if
of
you put
values.
an association in here, you know you're putting an association. I really think this is a nice syntax, but let's keep going. Okay, I'm not going to let's keep going for a minute.
Right. Well, yes, and yes.
I mean, and by the way, to criticize myself, okay, here, there is the question of what happens if we do this. And this is very analogous to the case of file system scan, right? Where you have a similar question of whether.
Yeah.
Right. Which obviously, if those were both sparse, or well, I don't know if it would normalize or not if you give it, two iterators, both of which are sparse arrays. But at
Let's
least
try
in
it.
principle, it could, right?
Okay, let's try this. That's weird and a bit crazy, if I might say so. I also don't quite know why those things are all red in the sparse array. Do you know why?
Because there are no numerical values.
Oh, I see. Okay,
Right.
so here,
If you'd done like plus or something, right? It would have.
yeah, okay, so let's do that, in fact.
Yeah, I mean, the reason it does that is because, so the iterator gives you a sparse array with different background values than the others. So you'd have to choose a background value for the whole thing. Now you could choose it as the background of each sparse array, but I don't know. I mean, it seems obscure enough that.
Well, you could bind the variables to the default value for each one and then apply
Right, exactly. I mean, it's sort of it's a special
I don't
thing, but
understand this. I mean, you're saying the point is that we can't. There's a background here, right? Because I don't understand why you have to produce this.
we
I don't
don't
understand why it
have
isn't
to
a two-dimensional array, sparse
If you
array.
want to call it a bug, you can call it a bug.
I
I
think
mean,
it's a bug.
I'm not sure producing a sparse array from the sparse array iter is that useful in the first place, but
Right.
I think it could be very useful.
Right. So what happens if you do sparse array of, %6 or whatever that is, right? I presume it'll compute some new background, or what will that do?
it'll compute a background of 0, which is the more useful sparse array.
Nice.
Right.
Look, I think it's super useful. I'd never thought of it, but I think it's super useful to have table work with sparse arrays because, this could be a huge sparse array and it's not going to do unnecessary work then. Whereas otherwise you'd have to densify it. Otherwise you'd have to use map basically on the sparse array, which also is not going to densify it. Make sense? I like this syntax, and I'm still pushing for this, which I don't think is crazy.
Yeah, but
although I don't.
Okay,
Yeah,
so
but what happens? Well, yeah, but what if J is 1, 2, 3? Not
so what if the sparse array is a matrix?
Okay, hold on. We're dealing with multiple things here. So this one here is J up to 3. What the heck does that do? Well, that's a strong argument that I see what you're saying. Well, I admit that I'm kind of toasted here. Well, no, I'm not. No, I'm not. No, there's an obvious thing to do here. The obvious thing to do is that this in fact determines that what has to happen is that it looks like this. Right? Blah, 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 like that, right? And so this one simply becomes list,
No, it would be the other way around. It would be an association of lists.
I never can remember which way around these go.
I can't either, which is why I was using nested table, because
the first, they go in order. The first is the most exterior, and then you go deeper.
Okay, all right, okay. So we got this the wrong way around, but the concept is the same.
Yeah, it's doable. I think the problem here is that we have an internal concept of list representations, and structure arrays, sparse arrays, and lists and packed arrays are listed representations, but associations are not.
Okay, but this will be a distinct change in what table does to make an association. I mean, how would you do this? We don't have an association table, right?
No. I think
Right,
it's
right.
doable. It just
But,
it may be work. It may be
Yeah.
non-trivial
No,
work.
I understand. I understand. I'm trying to come up with a design. I'm not saying we have to implement it, today.
right.
Mhm.
Well, yes, but right. But this is also right association map of f of pound.
It is, yes, it is. You could do this with association map, at least in one dimension. Okay. Question here about the sparse array, the two-dimensional sparse array.
Okay.
That is an interesting question. I mean, if we say table f of I, and we say now, I goes at what the heck do we do in this case? Sparse array of, 3, 4, arrow 5, 6, 7, arrow 2.
Right. So this is a representation of a list. I think you messed up your sparse. Yeah, you're missing a list around the inside of the sparse array, right? You need to surround those rules with a list, right? But it's going to treat this as a list. So just as you gave, if you gave it a normal matrix, it'll apply F to each row. It's applying F to each row of the sparse array.
I see. So it peels off the top level of that
Yep,
sparse
right.
array.
Yeah.
Oh, that makes sense. Yeah, that makes sense.
And I think in this case, the sparse result doesn't make sense. I mean, you could put sparse array around it, but it would take more memory than the list. And that's partly why the double iterator does something like that too.
Okay, hold on. Why are you saying that this is? I don't
I'll be right
understand
back.
this. I don't understand why it doesn't make sense to have a sparse array.
Well, the background of that sparse array is 0. Okay. So with the sparse array of background 0, you're storing all of those F elements explicitly. So it takes more memory than the table.
Okay, but in this case here, I'm not. Right? And that case there, I don't understand why this whole thing can't just be a sparse array.
That
I mean,
possibly could. It's going to take,
why is it going to take more memory? I don't understand. I mean, if I say
well,
sparse array,
that case won't, but the F case will. If the
Okay. The F case I'm less concerned about, but I mean, this case, if I say array rules here, it's a nice simple thing.
right. So when do we decide when it's nice and simple and when it's not?
Well, all I can say is that when we have a giant sparse array, we're going to be very happy that it's sparse and not
Right.
trying to densify itself.
But that's only going to happen when that thing inside the table is only going to happen when that's a listable function.
Okay, I see what you're saying.
Okay, I think there are possible optimizations here.
Yeah, right.
Yeah,
But I'm not.
There is
okay.
one more thing, another angle on this that we haven't talked about. These iterators work not just in table, but they work in do, things like do
Yes,
and sum and product.
yes. So
And
that was right. That was right there in the subject line.
Yes.
Yeah.
So
having
I think-
the thing turn in associations a little bit, the value thing would make sense for
Well,
those.
no. For do, for example, no. For do,
right, it doesn't return anything, right?
right. So it doesn't matter.
So,
It
so
just
what
evaluates
happens if
this
you do it in
function.
sum?
Okay, good question. Let's think about it. Okay, I'm not falling over yet. Okay, let's try this. Okay, so then we're saying sum of this. Okay, so normally, what would sum normally do? What does sum do?
Well, if you give it the list notation,
No, I know what it does in the list notation.
Yeah.
I mean,
And that's super useful. That's very nice, I think.
yes, it is nice.
So
I think it gives an error in this case. I mean, I think it would give an error if you put an
well,
association there.
we
ahead.
go from table to sum by changing list to plus. So if you apply plus, what happens in an
Well, I
association?
know that's what it's going to give an error, I think. I think this is so if you say
But
here,
no, because when you use apply, you lose the keys. So I think applying plus to an association will give you the sum of the values.
Mhm.
oh yeah,
So
so it's fine.
exactly.
Okay.
Okay.
All right, let's
Yes. And let's just talk a little bit about incremental objects
I
before.
know that's what I really want to talk about. That seemed to me to be the elephant here.
Yeah. So obviously this is new in 14.3 because right, incremental function is new in 14.3, and I think this mostly works in 14.3. But right, so here I've created a function that right returns multiples of the given number until you hit 100, and you can just stick that in as if it were a list, and it iterates over all of them until it's done. And as I showed, this really does work with all four functions. Um,
Okay,
so
hold on. Let me just think about this for a second. So
okay.
when you have this incremental function, and by the way, I mean, it is my assumption that we are going to get, like with data structure, we're going to get a bunch of standardized incremental functions. Is
Well,
that
they'll
true?
be called. I thought your design was incremental object, and I've been working on that.
Okay, but I mean, so for example, there'll be one that iterates over permutations or something. Is
Yes,
that right?
yes.
Sure.
That's I've implemented that.
Right. I'm yeah,
These are like
perhaps the
version.
last input is the last couple of inputs are the most interesting one. So here I've created one that, counts from in multiples from 0 to infinity. Which obviously you can't create a table with infinitely number elements, but I create the object, I iterate over it for some period of time, and it prints out some multiples. And then, I continue iterating over it, and it gives me some more multiples, etc.
Wow.
So, any sort of one of these incremental objects, it'll start wherever its current state is, and it'll go to its end. And if it
Right.
never
So
ends,
the,
you'll be
the
in
more
trouble.
interesting case is when there's a return here or a throw that breaks out of the table. And then you go back into the table with the iterator.
What do you mean if there's a throw, you go back
But
in?
I'm saying that what we would do is, does this work, by the way?
Yes, if you evaluate this, this works. This is why I told you to use the most recent build.
Okay. So now what I'm saying is, see,
Aha, yes.
it's kind of nice.
Right, yes, yes. So basically this you've implemented your terminating condition differently than I did, but yes, it's the same idea as my example, right?
Right.
And that could be do instead of table.
Exactly.
Yes.
Actually, it could be sum or product.
Yeah, right.
Yeah,
Okay, so
yes.
let's come back to what's really going on here. Okay. So I don't really quite understand. Okay, help me out with how the values of X are being returned from comp, whatever it is. How do I get from inf? How do I get the next value? Do I say this crazy thing with next? What do
Yep.
I do?
Well, that's going. There'll be a next value or something, but that's what you would do.
I
Yes.
believe it's just
Next.
next.
It's next. just next.
Right. So that'll give you 210 or, oh, interesting.
It's the same inf, so it's
Right. But why is it 217 and not 210 if we threw it
Yes,
because
that's
it's
what.
at
stateful. I
203?
mean, it keeps its state. Do it
No,
again.
Yeah,
no, I know,
but
but
why
maybe
wasn't
that
it state
error, maybe
203?
the error that I got caused it to evaluate once,
Ah, okay.
which seems questionable to me. I mean, if I just use inf there and now I say inf of next, but I didn't nextify it. Yeah, that's not right.
No, that's correct. The last time you evaluated it was 217 and
Oh,
now
I'm
you
sorry, I can't
next.
do my arithmetic. Yes.
Yeah.
But I think that error condition caused it to do, I mean, I'll demonstrate it. Let's just try.
No.
That's
Yeah,
working
there's
fine.
it might be something in the throw or the table is causing
All right,
one more
okay. So it's
evaluation.
a potential bug, but
Yeah, fine. Right. It's not, I'm just saying it might be
okay.
in.
So what I don't understand, and this is only temporarily a data structure, is that correct? That's going to be something else in the future. It's going to
Well,
be incremental
I
objects
think
in the future.
Well,
I
if
think
you
we
want
need
to
to
create
design
your own data structure, you should be able to, right? But
we need to design incremental object, and we can revisit this to your heart's content.
Okay. But then the main point is, look, I think we're a little bit early to, I mean, I think this is a very cool idea with table. Well, do I think it's a cool idea?
It's really useful.
and
Agreed.
sort of the point is like, anything that sort of implemented a similar sort of interface. So like if and I know Carlo wants to do this, right? Implement a next feature for video, at the compiler level. Maybe it's not user
Oh,
visible.
there's a top level. There's a top level way of doing this actually as well.
But I'm just saying, this is I was giving a specific example. I'm not talking about possible designs. Right? So, it and right, so you get it like one frame at a time, right? And then you do a table over your video.
One thing I'd really like is, let's say I've got this iterator, this incremental object, and I'm generating permutations or something, and I'm in the middle of deep in the middle of the permutations. Okay. I'm just thinking about this. I mean, I'm also thinking about parallel table. Right. And what happens with parallel table?
Well,
yeah, well, I don't think this really can.
No, but look, no, it's not true, because it can run parallel table is in chunks. Let's say I have 200 machines. Okay. Why isn't parallel table just saying, okay, incremental object, give me 200, give me the next 200 numbers. Fine, I'll send them out to my machines. Get them done.
well, it
Then the
requires
next 200
that you
numbers.
can start.
What's that?
You can skip over. You might have to skip over. I mean, it's a sequence of things, so you can't always just jump into the middle. You might or might not be able to jump into the middle.
I'm not saying that you're jumping into the middle. I'm saying that if what you're doing is parallel table here of I comma inf here, and by the way, we should check that parallel table works with those sparse array things and so on. Do you think it does?
Probably not, but
okay, well, so that's a thing that needs to be checked into.
Okay? The issue with that parallel table is if that expression XXX is relies on some side effects that breaks apart. You can definitely do the parallel extraction from the iteration, so the block extraction from the iteration and parallel evaluation of the expression.
Okay, but if it has side effects, you're toast anyway.
Yeah, and we do this with video, right? We can parallelize effectively table for video by extracting blocks of frames and parallelizing the evaluation.
Right. Yes, but in video, how many frames there are. Right?
Yes, that is true.
And there's random access to them as well, right? What you need is an iterator that is kind of random access so that each kernel can just, as Tom said, jump to the right one.
Well, video is not quite random access. As I said, we do sequential extraction of frames, but then the evaluation of the expression is parallel.
Okay.
Okay, but
no,
look.
The analogy to this is what I did at some point. This is years ago for the random generators. They're random generators that have this sort of skip ahead property. And you can say, you can have a certain scene. You can say, oh, if I can skip ahead such and such and get a block of those. And this is kind of the same thing. It would have to have, the iterator would have to have that property that you can kind of skip ahead.
That is an interesting question. Random integer versus incremental object. Because you could have an incremental object that is the random generator, right?
Yep.
Clearly, yes.
Okay, but what I'm saying is I don't think this is hopeless here at all. In other words, what I'm saying is what does parallel table do? Okay,
Well, right.
On the master machine, it runs the iterator, generates, X number of, it generates its next batch of things to evaluate, sends them to the,
Do that.
Well, it doesn't know how big the batch is, right? Because it doesn't know how many elements there are.
no,
Right.
no.
If you give it
Why
a
are you
list, it
saying
knows
that?
how many elements there
Stephen,
are.
Stephen,
And
it
so
could do.
knows how
It
to
could
split them
do.
up, and it can decide how to split them up. Here, it doesn't know how many elements there are. I suppose it could, find all of them and then decide.
No. Why are you guys? Maybe I'm missing something, but what I would imagine the algorithm is this. Okay. Every time. Okay, so we've got the weight. We've got the, Okay, let's say you've got 200 machines. Okay, 200 parallel things, parallel kernels you're going to run on. Okay.
Mhm.
The first thing that happens is it's like, okay, you might as well fill up every one of those. So you run the iterator 200 times to get 200 values. Okay. You send each of those
Assuming
values
you
to a
don't run out of values.
I'm sorry, what?
Assuming you don't run out of
And
values.
if you run out of values, then you're a happy person. Some of the machines can go to the beach that day.
Yes.
Okay.
I'm just being precise. That wasn't a criticism.
Yes. Okay. So then it runs those. Okay. So some of the machines return their values. Every time a machine returns its value to the master kernel runs the incremental object again and generates a new value and sends it to that machine and says, okay, keep working. That's it. It's as simple as that, I think.
Well, except that would be a terrible way to do it unless XXX was super expensive.
Well,
Right,
you're just saying you could buffer.
Because the way parallel table normally works, right, is it splits things up ahead of time and sends the limits, not.
Correct.
I understand. So you could buffer up a bunch of incremental
Yeah,
values.
you could buffer it up into blocks.
Yes,
of,
I mean we have a bunch of options to parallel table that decide how fine-grained or coarse-grained to make it.
Could work like that.
This is clearly doable. Okay, but in general with these iterators, I mean it's going to be very useful to see a bunch of standardized ones like permutations, like I don't know what we're going to. I mean,
I've implemented, like an identity, a range, a take, a select, and a permutation indices. So
I don't understand what the range. What are those? You
the
mean
range
range
is
just
like
means
what you have, the basic thing in table. So it
right?
just
Okay, fine. But I mean, but then there are
like
much
the
more
range
elaborate.
function.
I mean, there's things like iterating over graphs, let's say.
Yeah,
Right. Well, you'd need somebody to write code that,
Yes, that sequentially produces graphs, or iterating over.
I can do a bunch of some standard operations.
Yeah, like tuples, iterating over tuples. That's an obvious one.
Yeah, and some combinatorial. I don't consider.
Okay, so I mean, I've done this kind of thing many, many, many times. Of not with this incremental function thing, but I've done this thing where you have to, where you'd like to return results. Yes, I mean it's just a nicer way to organize the code. But
well, I should show you some of what I've done. So.
Fine. Okay. Can I? Okay, but roughly, there's going to be some kind of next value function, right?
It'll be whatever functions you want, Stephen. If you want a next value, you can have one.
I think that's probably what we want.
But that's fine. Yeah, sure.
And then next value comma n, or something like it, or next value list or something would make a list of these.
Right.
Well,
Right.
Table.
My expectation of, based on previous language design is that next value of n comma n would give you one thing, which is, having
yeah.
run next
Yeah,
n
you're right.
times.
You're
and
right,
next
You're
value
right. You're
list.
right. And there's the next value list will give you the whole thing.
Yep.
But hang on, you're writing table there, really. So
Well, yes. Just
Why am I
there's an
writing
incremental
table? I'm
object
sorry.
way
Wait
of
a
doing
minute.
this.
Why am I writing table here?
No, you could write table of
I, comma,
list.
that.
Yes.
But it doesn't say to do n iterations of it.
Right. Well, then there's another incremental object that says, give me n of these and stop.
Where do you put that?
When you put it outside, you nest it. Stephen, let's stop talking about this because I think I don't think you see all the possibilities. I should show
Okay.
you.
All right. Okay.
some of
I'm
this.
pretty sure we're going to want those functions. So
Well,
please
fine,
bring those up.
whatever. That's fine.
Okay. While we're at it, I just want to ask, what's happened to my friend, the module of typed?
Well, you asked that yesterday, and the answer's the same as yesterday.
When did I ask it yesterday? I asked somebody
We had a
else
meeting.
yesterday.
We had a meeting yesterday.
No, it was not yesterday, Tom.
It was yesterday.
Wait a minute. I'm going to look at my calendar because I don't believe
We
that.
had the GPU summit.
Oh, yes, we did.
You
Yes.
asked me that, and the answer's the same.
What was the answer again? I forgot.
Right, we need to have a meeting about this.
Okay,
And
fine.
we'll be setting
Oh,
it.
yeah, I remember that answer. Okay.
Right.
Okay.
right. So we spent a lot of time sort of on the middle bullet point here. Do we want to add video, audio, maybe time series?
Sorry, where? Which middle bullet point?
In that possible extensions, right? Allowing more data structures in the uh,
In the iterator, just like we talked about allowing association.
Well, we have lists, so we could have other things as well.
Right, like association.
Like association or like linked list or dynamic array or maybe even bit vector.
right, but also video, audio,
right. But then the feature of that
actual,
would...
things that people actually, know about.
Okay, so let me understand. If it's as if map, then I'm sort of happy with it. Like for example, if I say map F onto sparse array, right, that just works and gives a sparse array. If I do a map onto a video, what happens? I have to do video map, don't I?
That could work, but it doesn't. Yeah, you have to, at the moment, you have to do a different operation.
Yes, and I think there are real issues with doing
Agree.
map
Agreed.
on a video.
Okay,
Now,
so
The main issue is the third
this would
argument.
not be like map. This would be like, like incremental function, right? It would give you a list of f applied to the first thing that the object does, and then, the first frame, however we define frame. And then, the second.
I mean, to me, the semantics, it seems obvious, is table could do a variable binding version of what you could otherwise do with map. And anything that deviates from that seems problematic.
The difference with map is the third argument.
Yeah, I mean, that's...
But look, I mean, for example, this would follow my as if map criterion for putting associations into table.
Okay, well, certainly incremental function violates this rule already, as would incremental object.
I agree it does. Okay, but you're proposing... Okay.
I'm just saying this is something which has been requested, for example.
Yes, but why? Okay, how do I get what's the simplest video I can get?
Example data fetch dot mp4. Sorry, video of string of that.
Video.
No.
What?
No,
sorry.
he's saying not example data, video.
Yes, video of string example data /fetch.mp4. And yeah, that doesn't work for the moment. The equivalent of that is video map.
Okay, so I mean, we just like for images, although it's confused me several times, things like, wow, that's weird. It just absorbed the edge detect.
Well, it's an
That
atomic.
is
Atom.
It's what?
It's an atom, isn't it?
Or is it because edge detect on a string returns to string?
I am honestly confused about that. I'll look into it.
Okay, but what was I going to say?
The edge detect evaporates.
Why didn't that work?
Video frame map is what you want. Otherwise, you need to specify what attribute to the video you're mapping on.
Okay. That was very cool and very pretty fast as well. Oh, and it's playing music too. Okay.
Yes, but my
Why
claim,
did it get so much bigger?
but my
Why did
claim is you can't preserve the head in table.
I think it's crazy to put this into table. I mean, I think that you're starting to iterate over 2 videos and all kinds of weird stuff like this. It's crazy. I'm not a fan of putting that into table. Is
Okay.
everybody trying to support that or not?
I would like to, but I can bring a set of examples in another meeting to try and convince you, but I don't have any ready now.
Okay. Hey, by the way, Nick on our live stream, who might be here too, but is saying, what about replace list returning an iterator? That is an interesting idea.
Sure, yeah.
That's an interesting idea to have a version of replace list that returns an iterator. I mean, it's really not replace list.
You mean an
it's replace,
incremental object, but
yes, an incremental object.
yeah.
Okay, I'm not buying into any other data structures.
Okay.
Multiple iterators.
Right. Right. So So we currently right. So this means like, f of I, j with, list I, comma, whatever, j, comma, whatever. But you don't want the matrix. You still want the flat list, which obviously you can do. This is probably Steve, Tom, don't.
Go,
Yeah,
go,
okay.
go on. That's not what I suggested.
I
though.
know it's not. Which is
Fine,
which is why it's the third bullet point and not the first bullet point.
Okay, fine. Go ahead.
Stephen, you entirely skipped over the first bullet point.
Oh, sorry. Allow multiple variables to bind at once. I didn't understand what it meant. Sorry.
All right. So maybe you should look at the examples in the next section.
Oh, this is to auto flatten somehow.
Right. So the third bullet point is about auto flattening. The first bullet point is about something completely different. Skip over that. Go to multi-iterator. Right. So here you're sort of binding multiple variables and you're sort of iterating over them in step as opposed to independently.
Okay, so there's something that I keep on being bugged by, which is that I do a table and I really don't want the nested, table structure. I really just want everything flattened out. But I'm not going to use flatten because it's going to kill some inner lists that I have, et cetera, et cetera, et cetera. So I end up having to count my flattens and do it, flatten table, blah, 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 comma 2 or something, depending on how many iterators I have.
Right. So that is another possible extension, which I don't have a concrete proposal for today, because I was up till 4 finishing this proposal.
Yeah, this is complicated. But Stephen, you want the outer product but flattened.
Yeah, I mean, the thing that I could imagine would be something like, maybe this is crazy. No, this is pretty crazy. I don't know what syntax to use.
Right. And I'm going to argue that basically anything which is just a list with we've changed one thing inside is crazy. And that was what the previous section was about.
Well, this could be
but-
then a list of pairs, right?
What do you mean?
What you have there, I'm trying to complete your suggestion. I, comma J, and then a list of pairs. List 1, 2, 2, 3.
I see. Which wasn't really what I had in mind, but
No, you have to
you
have a
need
list
another
of
list.
Another,
yeah,
exactly.
right.
Yeah, and I'm not keen on this idea. I mean, or on this particular syntax. I mean, I understand the idea, and it's certainly something that, for example, Brett would love. And that's
But I mean, we could have a new function called flat table.
Look at that.
yeah, that's
Well, okay.
I was going
Fancy
to
that.
suggest flattened table or something, which did that.
Right.
And there'd also be a flat outer, which I
Mhm.
would find really useful too, because I
Yes.
never
Yeah,
remember how many levels to flatten it.
Yes. The tuples can produce this flat structure, and it's very useful.
Maybe we should consider making flat table a
yeah, that's yes. So that's solving the still want the outer product, but flatter. And yes, maybe that's a new function rather than putting yet another syntax into
I do like the idea of having flat table. I've needed it so damn many times.
right. Yeah,
I don't really like the name though, but flattened table.
Yeah, I thought flattened table would be the name, and
Flattened like this.
yeah, flattened table. Yeah, exactly like you wrote. Yeah,
Yeah.
and I think
Kind of
flattened outer would be super useful as well.
Well, outer has that weird thing. We should talk about outer because it has that weird thing of having that numerical argument in it.
Yeah,
yes.
maybe we shouldn't
One
bring up
that
outer.
almost
Sorry.
nobody knows about.
Let's bring that up in
I think
another
and then
LCC meeting.
I mean,
Okay, but I think
tuples
flattened table is a good idea.
Yeah.
tuples can produce the flat structure. So if you do tuples with a list of lists, but it's
Right.
missing the function. But this is pretty
Yeah,
useful
I know,
too.
but I find the list case much more useful. I hope the
Mm.
outer refers to tuples properly.
sure it does. And if it doesn't, I will fix it.
Yeah, it's the
Tuple.
first
That's the first C also.
Oh my gosh. Can I suggest that we put a tuples example in here, please?
Yep.
Right. So this is one problem, the flattened outer.
Yep.
Then there's also the problem of, what Sanders wants, which is, association and getting the keys and the value separately, or, which
do
is
you
a
mean? I'm sorry, I
variation,
didn't
the
understand.
general
Why
problem.
with the keys and the values separately? This one here.
Right.
Oh, it's iterating over a, oh boy. I see. So it's like a key value map.
Yes.
This is to table what key value map, what map is to key value map, table is to blah. Right? That's what's being asked here.
Yep.
So with the association syntax that I'm strongly proposing, this isn't what would work here because this would not do this thing.
Well,
Right.
this is not a normal iterator, right?
No, I know it's not a normal iterator, but I'm saying here,
Well, there you want it to be with a normal iterator.
well, I agree.
But Stephen, I think Sander wants the list out, right? He doesn't want an association, right?
I get it. I get it. He wants to do a key value map. I'm telling you, this is the missing function, if there is a missing function, right? Map is to key value map as table is to what?
Well, and I'm saying this could be table as part of this whole other set of things, which if you would actually paste a little bit of attention to the agenda. I was up past 4 a.m. preparing and then some
You
more.
already said that, so that was you increased the guilt level, so now I'm going to look at it more carefully. Okay.
Right.
Okay. So
Right. So, there's sort of the general problem of sometimes you want sort of the inner rather than the outer, right? You have multiple lists, and you want to sort of iterate over them in lockstep. And so, right. So
oh
there,
boy.
a few different,
But isn't that map
Especially
thread?
map thread.
Isn't that
uh,
exactly map thread?
But we want table.
and well, depends on exactly what we allow. In this simple case,
It's analogous to map thread.
yes.
See, I don't think it makes sense to reproduce every piece of map-like functionality inside table.
Stephen, when you're doing this table over like a list, okay, don't you ever sometimes want to counter to increment a counter? And that's quite awkward
I do. Yes,
currently.
sometimes
Right.
I do.
This solves that problem, you see.
Right, and I
That's
yeah,
exactly
right. So the 1, 2, 3, fourth input there is a proposal for specifically for that case because of
And why is this not a supplied play?
um
Because there's no function.
yeah,
But why not put a supplied around the... Could we not put, or am I being confused? A supplied
Supplied would
around
make
each
sense in array, but not in table.
right, because array table is looking at expressions, it's not applying a function. It's evaluating an expression.
Okay. I'm fairly confused here. I mean, I just think this is very ornate syntax that is not... I mean, maybe I'm just being silly about it, but I don't...
Okay.
I mean, I'm not
So
seeing
Brett,
this.
do you want to speak up in terms in support of the possible variant with the sequence and the transpose?
Sorry, which one
Down
exactly?
here.
I think this one is the thing you were asking me for yesterday. Is it not?
Right. So that's the one where, I've got a list of points, say like, I've got, 20 XYZ triples. And I want to do something complicated in terms of X, Y, and Z on those. And so I do things like, table of XYZ equals point, semicolon, my complicated thing. And then, my iterator is point out of the list of points.
I'm totally confused. Give me an example. So
Right.
we've got...
That is the example you wrote before, Stephen, without the multi-iterator and without sequence. It's XYZ binding to triples.
Right. Yes, this is it. So if you scroll down to the thing that Jose,
It's this case here.
yes,
Exactly. Yep. Which I think it's natural. And
Well,
I don't
that
see
we could support. We could support that actual form.
Mhm.
Right? Because you can't have a list on the left-hand side normally.
Right.
Do you need then a list of tuples in the second part of that list, or could it be just ij, comma 3?
You can have a
Well,
list, but nothing else.
okay, let's
Yep.
That seems
let's
fair.
look at the thing. That look, what you have to
Now,
do, this is
that
one
works
kind of
now.
corresponding thing, but then what this... Okay, here's a case that we could imagine. Is this case here. That means there's an array here that goes where I goes from 3 to 7 and J goes from 4 to 8.
Mhm.
As opposed to this, where I could go on and say A, B, C, D here.
Right.
And
wait,
if you change the 8 to a 7 and that's not that one, but the one after it, it's an error or something.
Which one? Where?
There.
No, it stops.
No,
Well,
why is
wait,
that
what are we proposing?
okay,
And
fine.
am I going to completely freak out here?
Go on, Itai.
I mean, what are we proposing? What are either of these inputs? They
Okay.
look
Okay.
completely
So
crazy to me.
Let's take the
this
second
one-
one first.
It's multi-set, right?
Well-
this one returns here f of 3,
3,
4,
4.
f of 7, 8, ...
Mhm.
Okay. This one returns, I'm going to change these numbers just to make it a little bit more obvious what's going on. That returns f of 1, 3,
F of 1, 4.
No, 2, 4.
No.
No, I think it should be the square, not the diagonal.
I think this is sorry.
So there is an
I
ambiguity
will say
here.
that this is completely insane, whatever.
I
No,
think
no,
this
no.
is fairly crazy because
Besides
this
the
is
fact
a
that you can't even agree on what this is returning.
I agree.
It has
I'm
two
gonna say that
interpretations. It's some sort
I'm
of
gonna say,
outer
wait,
or inner.
let me finish my sentence, please.
yeah. This is
I'm going to
crazy.
say that this is completely insane because it's way too easy to accidentally do this and
No, I agree. This one is no good. This one, however, I think is
Mhm.
interesting.
yeah, I mean, like I said, I still don't like the idea of overloading this, right? Because if that was f of ij, then rather than list ij, sorry, well, I shouldn't have used f. If that was g of ij rather than list of ij, that would bind g of ij to the list 3, 4, and then to the list 7, 8. And so this is sort of a very unstable-ish sort of structure, which is why I would prefer a new head here rather than trying to
But
overload.
why is it unstable? What's
I do like this because it's going to play well with symbolic arrays, like having a symbolic array in the first argument.
Um,
which first argument, here or
Instead
here?
of ij, it could be a vector of dimension 2. No, it would be an f of a v, where v is symbolic.
no, this cannot work. Well, I mean, I suppose
How do I get? Why do I have an extra bracket coming up? Okay, so you're saying this is like where we say, in a plot or something, we say, P is an element of disk or something
It's
like
a
this.
vector symbol, yes.
So what are you proposing here? Vector.
So we could have a vector symbol there of yeah. So if we have a vector symbol there and then a
This is
list
an
of
important other case. Is vector, vector symbol, etc., which we should talk about.
Well, those give error messages because I'm sure they do. Right, but let me actually finish my sentence for a change, which is, if you replace the list, if you take that first input in under
Yes.
multi-element, so
Yes.
copy that left-hand side. Okay, now replace the list ij with g of ij and hit evaluate.
G of ij?
Yep.
Okay. But I mean, that's the same thing as saying you can say G of 7 equals blah, but if I say list of 7, it doesn't work.
Yep. Yeah. List is special.
Yes. Right. I'm so maybe we need to go back to the short history lesson because we've made quote unquote small safe changes before and they've created an enormous amount of headache. Right. So deep racing
I love debracing. Debracing is one of my favorite features.
Yeah, and it was a terrible idea.
It's not a terrible idea.
It was a
that code
terrible
look much
idea,
better.
which created endless headaches, and there are still people that are unhappy because
What is debracing?
The
so
fact that when you do a table, if I want to say table of X7, I can just do that, and I don't have to say table of X list 7.
right, yes.
Okay.
But the point was that you know, the second syntax is unambiguous. The first syntax is ambiguous.
Sorry,
And
which first? X equals 3, and then this.
yes, that's ambiguous.
Why?
Because, well, take a look at the next one. Right? When there had to be a list there, then we knew that if it was a single element list, then it was just a count, and we did that. When it was debraced and now it was a symbol, then the question is, well, is that a max? Is it a list? Is it its own iterator? What the heck is this thing? And so after many bug reports and long discussions, which you've clearly forgotten, but we spend untold hours discussing this. Right, we settled on, if the symbol evaluates to a number, well, probably numeric Q, but then or I guess if it evaluates to anything except a list, then we take it as a max, which it had better be numeric Q if we want it to produce anything. And if it evaluates to a list, that's an error.
Yeah, well, that's because, I mean, the scoping of variables is shot to hell if you have something like this. I mean, Y is not a scoped variable properly if it comes in through that evaluation. I mean, I guess table is a blocking thing, not a moduling thing.
Correct.
Exactly.
So you're saying it could in principle work, but it doesn't work.
Well, then it caused other issues, which,
I just don't think you should do this. I think if you want to insert there, you should use with.
right, which is basically how we settled on this behavior. Right. I'm just saying that there are still people who think that, like Tali, for example, thinks this should work, but it evaluate exactly once at just the right, quote unquote, right time instead of end,
I think this is very questionable. Hey,
Right.
listen, I need to get going here. Can
Right.
we?
So let me just ask you, Stephen, do you still think the agenda I prepared was too short?
Okay. All right. It was correctly sized.
Right. So, okay. So we don't like the data structures. Wait a
minute, what do you mean we don't like the data structures? Oh, we don't like having video and things like that there. The
Yes.
question of whether we want to have linked lists and so on there, I think is for a separate time.
Right.
Okay.
Let's have an incremental object thing when we get further down the line.
I definitely think that's interesting.
Yeah.
Okay. And apparently we don't, and so we don't like Sanders' idea of having, some way.
I'm not a fan. I'm not a fan of that. I think this is a decent idea.
Okay.
No, I'm sorry, not the one that we said was crazy. The one, no, not that one. Sorry, the non-crazy one. This one here.
Yes, the first one. Yes.
Yes. I also think the association case is very sensible and interesting. I think 3 things here. I think flattened table is a good idea. I think the association case of table is a good idea. And I think this multi-element case is a good idea.
Flattened outer.
I think flattened outer is part of an outer discussion, which
Fine.
we need to have soon.
Okay. Carla, make sure to write that down. Otherwise I will forget.
Yeah.
Okay. Thanks a lot. See you guys soon.
Cheers, everyone.
Yeah.
Bye.